Okay, so what we're going to do is to skip the recap and directly go to a couple of examples to see how we can actually use the tools that we have right now to solve some questions. So first of all, I would like you to draw a circuit. And this circuit is going to have three resistors. Resistor 3, resistor 2 in the bottom, and resistor 1, which is on the right hand side. So 1, 2, 3, 3 resistor. All right, now let's give a battery total voltage of 12 volts. Okay, so 12 volt total voltage on the battery. And then, now let's randomly give the resistor some actual value. So let's say resistor 1 is 3 ohm, resistor 2 is 4 ohm, and resistor 3 is 2 ohm. Okay, so that's the resistance. Now, the question said, what are the values of I1, I2, and I3 in the circuit below? So I1, I2, and I3 is, well, the current going through R1, which is called I1, and the current going through I2, which is called R2, and the current going through R3, which is called I3. So we want to know the current. Now, but remember, we just learned about this Kirchhoff's law for series circuits, right? And we know that the amount current, which is equal to the amount of electron passing by the circuit per second, should not change at all. So that means if we can get the amount of current coming out from the battery, which is actually called I total, then it will be the same as I1, I2, and I3. So how do we get that? We have to transform this circuit into a circuit that only has one giant resistor. Okay, so now we have a V total and we have a R total. How do we do that? Well, we can do that by using the fact that we know R total is just R1 plus R2 plus R3. Now, because the three resistors in series, we can use the equation this way. So R1 plus R2 plus R3. So R total is usually one of the most important thing to find, one of the first thing you find. Now, in our case, it's going to be quite obvious. So we have a 3 ohm for R1, we have a 4 ohm for R2, and then we have, I believe, a 2 ohm for R3. So 2 ohm for R3, and if we add them all together, the total resistance is then 9 ohms in total. So that's the total resistance. So what can we do with total resistance? If we have total resistance and total voltage, which is 12 volts, then we can get total current. The funny thing is, the total current that we get in here is going to be exactly the same as the total current from the previous diagram before we simplify it. It's the same value, the same total current. So if you can get the total current in this simplified form of the circuit, when we combine all the resistors together, then we can get the same total current in the unsimplified picture in the original question. So what do? Is we're going to apply Ohm's law into this situation. So Ohm's law is V equal IR. But more precisely, we can actually say V total equals I total or total. So if you're talking about total, as long as all 3 points or all 3 of these values are total, we can actually do it together. So V total is 12 volts, I total is the unknown, R total is 9 ohms. So we have this. So therefore, I total is equal to 12 divided by 9, which in this case, it will be 1.33 M. And that is the answer to all the questions that they asked us, because this is also, well, IA or I1, which is also I2, which is also I3, because you do not eat the delivery guy, right? So once we get I total and there's only one pathway, that same I total is the same for going into resistor 1, same number of electron going to resistor 2, and same number of electron going to resistor number 3. Okay, now some of you might be asking, okay, so cool. So that's how I get I1, I2, I3. But what if I want to find out more? What if I want to find out exactly how many pizza they eat, like each of the customer eat? Now, Ohm's law is actually very special. I know that's not what this question is asking, but we're going to do one for example. Ohm's law is really special. You can actually use Ohm's law in every point of the circuit. Now we just use Ohm's law on the battery. Now let me help you with this. Let's do Ohm's law. So now we are back to the big drawing. Let's do Ohm's law to resistor 1. So Ohm's law says V equal IR. So it will be I1 R1. But what is I1? Well, I1 is the same as I total, right? We just did that earlier. So that actually become 1.33 times 3. So let's take a calculator. So 1.33 times 3. So that is going to be almost 4. So let's say almost 4. So it's going to be about 4 volts. All right. So now look at this number and kind of, okay, keep it in the back of your mind. And you can do the same thing for resistor 2 and resistor 3. And what you will find out is, well, let's see. Resistor 2 is going to be I times R2. So 1.33 times 4, which is going to be about 5.3. So 5.3 volts. And you can do the same thing with resistor 3. So resistor 3 is, well, voltage drop at 3 is equal to I3 times R3. So I3 is 1.33, R3 is 2. So that is going to get you 2.7 approximately. Now, ladies and gentlemen, 2.7 volt, right? Approximately. But ladies and gentlemen, if you add up V1, V2, and V3 together, what do you get? 4 plus 5.3 plus 2.7 is exactly 12. See how many pizza you pick up from the battery equals to how many pizzas you have to drop at each of the resistor in total if you only have one way to go. And that's how you can actually determine how many pizza you have to drop in resistor 1, resistor 2, and resistor 3. So the important thing is to get current. If you have the current, the amount of electron going through that resistor, if you have the current figured out, then you can just do a simple Ohm's law at that location to figure out the amount of voltage drop at that point. And technically, when I'm doing this question, I could have just done R1 and R2. And I don't even have to do the third one. Because, think about it, if I know V1 is a 4 volt drop and V2 is a 5.3 volt drop, but I know that I pick up 12 pizza from Pizza Hut, well, then the rest of it, 12 minus V1 minus V2 must be V3. So I technically don't even have to do the calculation for V3. Because I know if I know how much is dropped between the first one and the second one, then the third one has to make up the remaining number of pizza that I pick up from the Pizza Hut. So that's how you solve a entire circuit. Now you have all the current, all the resistance, and all the voltage drop. Now, so we just do one more example. Okay. So again, it's missing a picture. So we're going to be doing that in here. So we're going to have a parallel circuit. So this time, so parallel, so draw a resistor, draw a battery first, and then let's draw like 3 resistor. So resistor, resistor, and also resistor. Okay, so now it's going to be resistor 1, which is 40 ohm. Resistor 2 is an unknown. We don't know how big that is. Resistor 3 is going to be 60 ohms. And the total voltage from the battery is 24 volts. So you pick up 24 volts, 24 pizza. And for some reason, they put an ammeter in here. And the ammeter measures a current that is 1.8 amp. Okay, so that's part of the question. So the unknown is R2. So you're looking for R2. Okay. Now, so you're looking for R2. So how do we do this? Well, a lot of the time when you have more than one resistor, the first thing you do is to combine it into one and just hope for the best. Well, since we don't have a clear way to start, let's do that. Combine it into one resistor. So we can combine it into just a single one, which is R total. And we have our V total, which is 24 volts still. And now that current, that current that we got, the one that I'm highlighting in yellow right now, that current that we got is the current directly coming out from the battery before splitting up, right? Splitting up will be after. If you see the first junction point, splitting up comes after. After you get to this junction point in green, then you get to split up. But before you get to that junction point, all the electrons are still together. You're still all walking one way. You haven't spread up yet. So this I that we got in there is actually I total, which I'm going to draw it on the right-hand side diagram right now. So we actually have I total. Okay, 1.8 M is actually the I total. Well, now let me move over there. Well, with I total and V total, we can get R total. That's easy. So let's do an Ohm's law. So let me separate the last question from this one a little bit, like this. Okay, so let's do an Ohm's law. So we're going to do Ohm's law. V total equals to I total, R total. And having that, so 24 volts is equal to I total, which is 1.8, R total, which is the unknown. So divide both sides by 1.8. We are going to get the total resistor. So total resistance is equal to 13.33 ohms. Okay, so that will be the total resistance in the other diagram too. Now, but in order to find this though, now these three resistors are collected in series. You can see the three of them is they are collected in parallel, not in series. The last question was in series. So they're collected in parallel. That means the equation to actually find the total resistance is the one with the reciprocal thing. So 1 over R total equal 1 over R1 plus 1 over R2 plus 1 over R3. Now, here is a calculator challenge. If R total is 13.33, R1 is 40, R2 is unknown, R3 is 60, can you get R2? Right? Now, you only have one thing you don't know, but can you get it? So, take out your calculator and actually do this right now. And that's the end of our notes for today. We'll go through a few more questions. We'll tackle some harder one. Now, if you want to try some of the question, in the worksheet number 2, in the back of the note, question 1 to the first few one, there are like 18 questions in total, I think. But the first half of it, you should be able to do at this point. And if you couldn't, don't worry about it. We are going to go over every single one of those questions next time when I come back, if you have any problems with them. So now in this question, I should give you the answer. So you should be pausing the video, trying it. Now, I'm assuming that you have tried it already. And it's going to be 30 ohm. Okay, so if you got 30 ohm, good. If you didn't, it's time to figure out why. Ask your neighbor, right? Or ask me when I come back. It should be a calculator. Well, I mean, it should be a mechanical calculation problem instead of physics problem at this point, right? Okay, so that's it. Worksheet number 2, don't do the whole thing. There are a lot of questions on that worksheet, spanning pages, right? Just try 1 to 8. Okay, and if there are questions that you do not understand what's happening, circle them and tell me about that next class. All right, and I will go through them with you. And that's it for today. Thank you so much.